Okay, the second video on permutations versus combinations, I'm going to be showing you how to calculate the possibilities for a permutation. Remember, a permutation, the order does not matter, or the order does matter, and combination, the orders do not matter. So first I'm going to show you the easier one, the permutations. Okay, so I'm going to start out with number 5. It says these two people are planning a trip to 3 different countries. They're going to 3 different countries. There are 7 countries they will like to visit. One trip will be 1 week long, another trip 2 days, and the other trip will be 2 weeks. So I got a set of 7 countries they need to choose from. And the order is going to matter because one country could be 1 week, and the next country that they decide on could be 2 days, or they can reverse them. Or the third one, it's going to matter which one is first, which one is second, which one is third. Okay, out of the set of 7. So if I have 7 countries in the set, I'm visiting 3 of them, how many orders can I make out of those 3, out of that set of 7? Okay, so I got 1, 2, 3 countries, okay, that I need to choose. And out of the 7, so since my set is 7, I go 7, 6, and 5. Like I got 3 choices, so I go 7, 6, 5, and you're going to multiply these. You're going to go 7 times 6 times 5, and that will tell you how many permutations you can produce. So on the calculator, let's see, you want to go 7 times, or I'm going 6 times 5 is 30, and then times 7 comes out to 210. So there are 210 different ways that they could rearrange these 7 countries into a set of 3 if the order matters. Okay, so you got to look at how many is in your set and then how many you're choosing out of that set. So I go 7, 6, 7, 6, 5, you multiply them, and that'll tell you how many permutations or how many different ways you can rearrange these 7 into 3 sets with the order mattering. Okay, let's try another one. It says here, you are setting the combination on a 3-digit lock. You want to use the numbers 1, 2, 3, but you don't care what the order they are in. Well, you got to set the lock, the order. This is kind of a trick question because you don't care, but the order is going to matter. You can't just set the first number 3 and then 2, then 1, and if the lock is set to be 1, 2, 3. So how many? So here it is going to be a permutation. Okay, this is going. I'm going to put a P for permutation. Okay, so how many different ways can you arrange these 3 numbers to make the combination? Well, again, I got 3 numbers. I'm going to use all 3 of them. So here I'm going to go, the highest number is 3, 2, then 1, and then you multiply them. Okay, so therefore if I go 3 times 2 is 6, times 1, that'll equal, there are 6. There are 6 different ways. It's just like you saw here at the very beginning, but here I used ABC. So here the answer will be 6 different permutations. Okay, let me try or find another one here. Number 11. Let's look at number 11 as another permutation. This is a permutation. Because here it says I got a student body of 10 students. I have 10 students that want to run for president, vice president, secretary, and treasurer. Okay, so out of those 10 students, the order is going to matter. Which student is going to be president, which one's going to be vice president, secretary, and treasurer. So therefore, this is going to be a permutation. So out of those 10 students, how many different ways can they be rearranged into these different jobs? Okay, how many different sets can we make? So here I got 1, 2, 3, 4 different positions. 1, 2, 3, 4 out of a set of 10. So I got to go to the highest numbers, 10, 9, 8, 7. And then you multiply these. Okay, so therefore I go, there's 10 times 9 times 8 times 7. So I do this on the calculator. I go, turn it on here. I go 10 times 9 times 8 times 7 equals, so there's 5,040 different ways. There with just 10 kids with 4 different positions, okay, and the order does matter. There are 5,040 different combinations you can make. Okay, so you can see your chances if you just randomly pick in horse racing, it's chances are pretty small you're going to win something. Okay, if you're doing multiple, more than one racer. Just like here, that if you just randomly pick 4 kids and saying which one's going to be president, vice president, secretary, and treasurer, you got 5,040 different ways you can arrange these 10 kids into a set of 4. Okay, so that's how you do the permutations. And I think the last video, or second to the last video, I got a couple more on here. So the next video will how to do combinations, where the order does not matter.